Aloha class, Algebra 2. Today we are starting section chapter 5. Starting chapter 5, we started obviously with section 5.1, which is polynomial functions. And all we're going to do here to start off chapter 5 is we are going to classify our polynomials and also learn about polynomials and behaviors, okay? So in your notes, make sure you take a note of our title and always our objective. Okay, guys? All right, here we go. Key concept, okay, standard form of a polynomial function. Now, the standard form is we list these in decreasing degree. So if you look at it, it goes x to the third, x squared, x to the first, and then no x. Okay, and each one of these guys have a name. Okay, now for example, for this particular polynomial right here, if it's x cubed, that's called our cubic term. X squared is our quadratic term. X to the first is our linear term. And if there is no x or variable on it, we call that a constant term. There's a couple other ones you want to know, and that would be if we had something x to the fourth. That would be a quartic term. Okay, that's our quartic term. And then the other one that we want you to know is x to the fifth, because it's just cool. That is quintic term. Okay, and that's as much as you need to know. Once you get higher than 5, like if it was x to the 6th, you would say that's your 6th degree term. Okay, and so make sure you pay attention to those names. We'll go over those as we name these guys. And that's exactly what we're doing right now. We're just going to punch out a whole bunch of these guys, and I'm going to show you how we classify them not only by degree, but by the number of terms. Okay, if we look at number 8, 8 is 7x plus 3x plus 5. Hopefully you're noticing at home, hey, Mr. T, I can combine a couple of those bad boys, right? Swing, swing. And that would give me a 10x plus 5. So if there is any combining or simplifying you can do, you've got to do that. And then we're going to go ahead and name it. And it says to name it by its degree and its number of terms. Now, degree is the biggest degree. And this biggest degree would be what we call x to the first. So that means we would call this guy a linear. And then how many terms are there? Okay, because I could say linear polynomial, but usually we only use the word polynomial if it's more than 3 terms. So if it's 3, 2, or 1 terms, they have special names. Kind of like your last name, it's special. We want to make sure we use it. Now there's 2 terms here. So linear stands for x to the first, and 2 terms would be a linear binomial. That's it. You can have some questions that easy on your next quiz and on your next test. All right, let's go ahead and go to another one. I like number 13. Okay, 13, 5a squared plus 3a cubed plus 1. So when you're taking, those standardized tests like the SAT, they'll always want you to write your final answer in what we call descending form. So that means you're going to put your highest degree first, and then you're just going to descend, right? If you notice, we're missing that a to the first. That's okay. We're just naming these guys. And there's nothing we can combine because there's no like terms here. So there's 3 of them. But we first name it by its degree. And its highest degree is right there, 3. What do we call 3? If you remember from the previous page, we call that a cubic. And then we have 1, 2, 3 terms. 3 terms would be what we call a trinomial. So that's what we call a cubic trinomial. Okay, guys? Let's see, where else can we get a little bit tougher? I guess let's go to 19. And then I think, 19. We'll do 17 first, and then we're going to do 19. All right, 17 is 7x to the third minus 10x to the third plus 1x to the third. Oh my gosh, they're all to the third. So what do we do in this situation? Well, we simplify. That gives me a negative 3x to the third. And snappity dappity, we can do that again. That gives me a negative 2x to the third. So remember, whenever we name it, we always use its degree first. This degree, the highest degree is 3. So once again, this is a cubic. And then there's only one dude. Guess what? That is what we call a monomial. That's it. Okay, so it's a cubic monomial. So 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial. Anything bigger than 3, we just call polys. Okay, we call it a polynomial. Okay, and then let's go to this last guy. I said I wanted to do 19, remember? X squared minus x to the fourth plus 2x squared. We can combine those 2 guys, and let's write it in descending order. Okay, so I get that. My highest degree is a 4. Remember, that's what we call what do we call that? Do you guys remember from before? We call that a quartic. A quartic. And there's two terms, 1, 2. So it's a quartic binomial. Remember, if it had to the fifth, it would be quintic. Okay? Once again, one term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and 4 or higher is a polynomial. Okay? I guess I could maybe throw in one last example here. Let's say we have 7x to the 6th plus 4x to the 3rd minus 9x squared minus 4. Okay, can't combine any of those guys. The highest degree is 6. We don't have a special name for that, so we call it the 6th degree. 1, 2, 3, 4. And if we have 4 or more terms, it's a polynomial. Okay, and we didn't have any of those up there, so I wanted to give you one more. Oh, quintic, right? X to the 5th, that would be a quintic. And that'd be a monomial in that situation. Okay, let's keep rolling here. Now it says, and this is our last page here, so there are going to be some notes that go with this before we can attack it, okay? They're asking us to describe the end behaviors, okay? And I think the best way to understand what's going on is we're just going to do some examples, okay? So here we go. Make sure you're taking good notes right here, okay? Example Ichiban. Okay, so for our first example, let's go ahead and say we have some function, y equals. Let's go with 3x to the 4th plus 2x squared minus 9. Okay, now we're trying to describe its end behavior and the amount of turning points that this particular polynomial could have. Now remember, this is called a quartic trinomial. Okay, this is a quartic trinomial, 4 being quartic, 3 terms being a trinomial. And how do we describe its end behavior? To describe its end behavior, you just look at what we call the leading term, okay? And in the leading term, if your exponent is even, if it's even, your end behaviors both go up or they both go down. Okay, that easy. Both go up or they both go down. Okay, now to determine whether they both go up or they both go down, you now have to look at what's in front. Okay, what's in front there? It's 3. We don't care if that's even or odd. We just care if that dude is positive or negative. If it's positive, which it is in this case, what's your guess at home? Well, I don't know. Positive makes me want to go, right? So that's what happens. Okay, if it's positive, it tells us what its end behavior does, and that means it goes up. And since it's a even right here, since it's even right there, they both go up. So we go up, up. Those are our unbehaviors. And that's how our math Excel does it. So we'll do that also. It goes up and up. And then we look at that leading term right there, which is an x to the 4th. Sorry, you got a little sloppy there. And the turning points, the TPs, I guess I'll write it out the first time. Turning points, okay, would be that degree minus 1. So it could have at most 3 TPs. Okay, at most 3 TPs. Now, what would that mean? Here's a particular example, okay? This means it's got to start up, and it's got to end up, and it could have 3 turning points. Let's just draw something. Ichi, ni, san. There you go. That is what that particular graph could look like, okay? Has at most 3. That means it could have 3, or it could actually have 1 turning point, right? Or it could have 1. So it could look like that also. But both end behaviors have to go up. Now, I'm sure I confused a lot of you. So that's the power of examples, okay? Example 2. All right, let's go y equals. Let's go with negative 4x to the 6th plus 3x minus 1. All right, well, what do we do here? Well, Mr. T, well, first off, that's a 6th degree trinomial. We look at this when we ask about end behaviors and turning points. That's an even exponent. Since it's an even exponent, they both go up or they both go down. And remember, to decide whether they both go up or they both go down, we just look at the front and we say, is it negative or positive? If it's negative, guess what? They both go downers. Okay, so we go down and down, down to down. That's what happens with this guy. Once again, they will go in the same direction if your exponent is even. Okay, and then what's our turning point? Our TPs, we are going to say at most 6 minus 1, which is 5 TPs. P's. Okay, and that actually means it could have 5 minus 2, which is 3, and it would be all the odds. It could have 5, 3, or 1 turning points. So if it goes down and it goes down, and it could have 5, let's draw what it would look like. 1 turn, 2 turns, 3 turns, 4 turns, 5 turns. There you go, 1, 2, 3, 4, 5. Could have 3 turns, but it's got to start down and end down. 1, 2, 3. See, and it still works out every time. Could have 1 turn. Schlink. Okay, so it could look at like any of those 3. That is what it means. Okay, guys? All right, let's keep rolling. You guys are probably saying, but Mr. Tanaka, what the heck happens in example 3 if, oh snap, if the leading guy was odd? Whoa, first off, this is a quintic polynomial, right? Quintic because of the 5, 1, 2, 3, 4, polynomial. All right, so we look at the leading term if the question asks the end behavior and its turning points. Okay, and remember, if this was even, they both go up, they both go down. So guess what happens here? They go in different directions. All right, Mr. T, how am I supposed to decide which one goes up and which one goes down? Because they're going to be different. Believe it or not, it's this simple. It's going to end up whatever the guy in front is. So since that guy is positive out in front, it's going to end up. Okay, that's what it does. It ends up, whatever it is there. So if it ends up, where does it have to start, class? It's got to start down. So it's going to go down to up, okay? Because that 6 is positive, it's going to end up. And then what do we do for TPs? Is there anything special for TPs? Guess what, class? There is not. TPs are 5 minus ichi equals 4. So you could have 4 turning points. Now remember, it means you could have 4, you could have 2 turning points, or 0 turning points, which is impossible. Okay? So there we go. Or I guess it could have 0. It would be a linear equation. So it could be 0. All right, so here we go. So what would this guy look like? It's going to end down. It's going to start down. It's going to end up. And let's do it with 4. 1, 2, 3, 4. Booyah! Or it could be 2 turning points. 1, 2. Or, believe it or not, it could be 0 turning points. Okay? Okay, guys, there we go. Let's keep going. Now you're probably saying, yo, Mr. Tanaka, what would possibly happen if it was y equals, let's say it's negative out in front this time, negative 4x, but it still needs to be odd minus, let's just go 3x, 2 terms. That's a cubic binomial. Okay, and once again, it's odd out there in front. If it's odd out in front, they go in different directions, right? You can do little dance moves. So which way does it go? They got to go different directions, right? Why do they got to go different directions? Because that leading term out there is odd. So what did I say? I said you look in the front and that's where it's going to end up. So since in front it's negative, it's going to end up negative. Well, if it ends up negative, that means it ends up downers. That means it's got to start up. And then how many TPs would I have? How many turning points would we have here? Okay, we would have 3 minus 1, which would be you would have 2 or 0 TPs. At most 2 turning points. Okay, so what the heck would this bad boy look like? Well, it's got to start up. It's got to end down. And 2 turning points. Ichi, ni. 1, 2. Right? Follows beautifully. Or it could just look like that with no turning points. And that's it, class. That is it. Let's do 2. Okay, we'll do 2 of these guys together and see how you do. Let's do 27. 27. Okay, and I'm not going to draw these out. Okay, we're just going to look. That would be a seventh degree trinomial because there's 3 of them. And we want to talk about end behaviors. Well, that's odd, so they're opposite, right? Opposite directions if it's odd. Whatever's in front tells you where it's going to end up. So since it's negative, it's going to end up down. Well, if it ends up down and they have to be different, it's going to be up. And then what are my TPs? My TPs would be 7 minus 1, which would be at most 6 TPs, which that means 6, 4, 2, or 0 turning points. Okay? All right, last one, and then we're going to call it a lesson. We're going to do 31 because some people would butcher 31 here. So let's go ahead and take a look at it. 31 says y equals 5 minus 17x to the 7th plus 9x to the 10th. Remember how important it is to reorder these bad boys, right? You got to reorder them in decreasing order, okay? And that also always helps with describing our end behaviors. Also in our turning points, because now we know what the leading term is. Oh, 10 is even, so they're both up or they're both down. Remember, we look in front to see what it is. Now it's positive, and that means it's going to end up positive, and they got to be the same. So positive, positive means up and up, right? And then TPs would be 10 minus 1, which would be at most, right? At most 9 TPs. So what could the possibilities be? 9, 7, 5, 3, or Ichi. Boom, boom, boom. That is the lesson. Keep on working hard. Come in early if you got your questions. Aloha.